This is exercise number 10, page 687, section 22C.2. Hasten Harris, IB Mathematics, higher level. Here we go. So, an object has an initial velocity of 20 meters per second. So right away we know that V of 0 is equal to 20. And the acceleration is 4e to the negative t over 20 meters per second. Show that as t increases, the object approaches a limiting velocity. So I got to find a function for velocity. And the integral of acceleration gives me velocity. So I'm going to take the integral of the velocity function, or the acceleration function, to get velocity. So v of t is going to equal the integral of 4e to the negative t over 20 dt. Okay? And so that's of the form e to the ax plus b, where b is 0. So that's an easy integral. So that's going to be 4 multiplied by 1 over negative 1/20 times e to the negative t over 20 plus c. And so 1 over 20 is negative 20, so that becomes negative 80 e to the negative t over 20 plus c. But we know that v of 0 is equal to 20, so that means that 20 is equal to negative 80e to the 0 power. 0 over 20 is 0, and anything to the 0 is 1, so 20 equals negative 80 plus c, which implies that our constant is equal to 100. Okay, so that means that our velocity function, v of t, is equal to negative 80 e to the negative t over 20 plus 100. Okay. So we still haven't answered the question yet. It says it has a limiting velocity, which means it's not going to go over a certain velocity or below a certain velocity. And let's show as t increases. Well, it doesn't give us a bound, so really what we're doing is we're taking a look at the velocity function as t goes to infinity. So the limit as t goes into infinity of negative 80 e to the negative t over 20 plus 100, let's just think about this. It's not all that difficult, as let's see, t goes to infinity, then we have infinity over, well, let's think about this. I'm sorry, I need to rewrite this, sorry. Negative 80 e to the negative t over 20. So we can rewrite this as the limit as t goes to infinity of negative 80 over e to the t over 20. Yes? So e to the t over 20, as t gets larger and larger and larger, this is going to go to infinity, the denominator. And negative 80 over this is going to go to 0. Negative 80 over large is going to go to 0. So we still have the plus 100. So we know that this is going to 0, so that means that the limit is simply going to be 100. So the limiting velocity is 100 meters per second. Okay, because this term goes away as t goes to infinity. B, find the total distance traveled in the first 10 seconds of motion. So let's take a look at this. The velocity from, let's see, so v of t is greater than 0, right? v of t is greater than 0. And that is for 0 to 10, less than or equal to t, less than or equal to 10. How do I know that? Well, because from 0 to 10, this value is never going to be greater than 100. It's going to be negative 80 over, I shouldn't say greater than 100. It's never going to be less than negative 100. It's never going to, negative 80 over e to the t over 20 is never going to become a negative number. The absolute value of the negative number is never going to be greater than 100. So the reason I'm hemming and hawing and driving home that point is the total distance traveled is equivalent to the displacement. So I don't have to do a sign diagram because there is no change of direction and velocity. I suppose the easier way to think about that is if I had set this equal to 0, I would get no solutions. What would that look like? Negative 80 e to the t over 20 equal to 100? Not possible. Okay, there's no value of t that would give us this. It's going to be a negative value, and this is positive, so it will never equal 0, so it will never change direction, which is good news, because then I just have to take the integral s of 10, I was going to put s of t, s of 10 is equal to the integral from 0 to 10 of the velocity function, because the integral of velocity gives us displacement. So we take the integral of that function, so that would be what? 100, or negative 80 e to the negative t over 20 plus 100 dt. Okay, and that is equal to, I'm running out of room here, tough darts. Let's see, this is going to be, again, this is in the form of e to the negative, or e to the ax plus b is 0. So I'm just going to cut to the chase. You know how to integrate that. This term becomes positive 1600 multiplied by the negative 80. 1600 e to the negative t over 20. And then, of course, the integral of 100, t over 20, sorry. The integral of 100 is 100t. And if we evaluate that from 0 to 10, that would give us 370.4 meters. And there you have it. That is all. I am out.